Okay, so now we'll start our third video of this 4-video series where we're reviewing a pre-existing data analysis pipeline that's generated to both simulate and analyze and process data related to locomotor adaptation. So in this third video, we'll walk through a set of code that fits a model to our data. And so what we'll be doing is fitting a model to each participant's data and extracting parameters related to that model that characterize how that individual modifies their walking pattern through the course of adaptation. So we're here in our S3 script, and the first thing we're going to do is move into our simulated adaptation folder. And just as a reminder, the scripts live in this folder here. I've named this adaptation simulation, and we're going to move into this folder where our data were stored. So I will highlight that, right-click, evaluate selection. The next thing that we'll do is load a mat file that contains all of our compiled data. So in the last video, we compiled our data, and if we go to our directory current folder here, let's see, we should, oh yeah, I think I still need to run this line of code. So let me go back here, combine my data. Let's see, I'm gonna run this again. It's gonna ask me again if my data seem reasonable, sure. So what I want to do here is just run through this again because I don't have the compiled data file. Sure. Okay. So now if I go back to my S3 script, go check this folder, I should have this variable data underscore all. And what I'm going to do now is load this data. So again, when I have data that's stored in, as a mat file, so a proprietary MATLAB format, I can just use load to pull that data into my workspace. So I'm going to highlight this, evaluate selection, and when I go back to my command window, I see I have this variable data here. So what's included in data? So if I just type the name, again, data is a structure, so you want to be comfortable understanding the different types of variables available in MATLAB. I press enter and I see that this structure has 20 fields, or it's a 20 by 1 structure. So I have essentially one level or one set of information for each of my 20 synthetic participants. And for each participant, I have these 4 fields. So SLA is the actual data that we want to analyze. Good data is just a flag that we created in the last set of steps that denotes whether or not we think that data set is reasonable. And then we generated some artificial values for age and weight. Okay? This is just an example of how you might form a data structure in MATLAB. So next, what we're going to do is perhaps a bit advanced for most people if they're just beginning. But there are, I would say, maybe 2 more major concepts to highlight in this piece of code that we haven't already covered. The first is what we're going to do is fit a model to the data, as I said earlier. And just like R or even Python, there are many different methods that you can use to fit models to your data. Here, we're going to fit something called a nonlinear model. And specifically, this model is a dual or double exponential. And if you look back in one of the first videos where we talked about the intro to data analysis, the equation for that model is shown on the slides. So when we're fitting a nonlinear model in MATLAB, first we're going to use a function called fit NLM here. So this is fitting a nonlinear model. And again, whenever you're dealing with functions in MATLAB, you want to make sure you understand what the arguments or inputs are for that function. So in this case, we have 4 different inputs. I think that number is correct. So the first input would be essentially, you can think about these as the x values. Okay, so for each participant, I'm going to have some number of strides, and I'm going to create a vector that just indicates which stride number we're on as we move through the data set. One thing we do here is that we update this through our for loop, as we've done in other videos. And so this is a piece of code where, again, we're trying to make sure that we can automate things. So let's say that we want to consider the number of strides in our analysis. Well, that number is going to vary from one participant to the next. So what we want to do is we want to take that data structure and extract the number of steps or strides for that person. And that's what this section of code in blue is doing. And so I'll show you how this works in the main window, and then you can try this on your own as well. So let's say I wanted to know how many strides my 10th participant took. So if I just type data of 10, right, I'm dealing with a structure, so it's going to give me the same fields. Now I could manually just write down 980, but that's not an automated and easily reproducible process. Instead, I want to write a line of code that automatically extracts this value 980. So one way that I know that this is a vector, SLA, and when I want to count the number of elements in a vector, I use the function numL. So typically this is how I build a line of code. Okay. Next, I need to make sure that I tell MATLAB what vector I want to use. So in this case, it's data 10, and then I use the dot indexing to specify SLA. So this should give me the 980, and there we go. So now that this works for my 10th participant, what I would do is change this 10 to my indexing variable. So if I go back here, my indexing variable is participant underscore num, so I can copy that. If I paste it here, now I have the number of elements that varies for each participant based on how many strides they take. Okay. So this is just an example of how you can build a section of your code that is modifiable or changes throughout each loop. Okay, so fit in LM, again, the first input is the stride number that corresponds to the number of strides that I have, or vector. The second input would be the y values. So if you think about plotting SLA as a function of stride number, SLA would be the y value. So you can think about this as sort of any 2D function where you might like to fit a line to data as an example. In this case, we're fitting a curve. So those are my first two inputs. My third input is the model that I would like to fit. Okay, so if I hover over this, you can see that MATLAB pops up a tip that tells you what you need for each of the different inputs. And so let's look at our model briefly. So if I scroll up, there's a line of code here where we define this double EXP model. And so when we define our model, we have a few things. Okay? So in this case, we have two variables one parameter and one variable that we want to use in our model. So the parameter is a vector called coef. Okay, so this is a vector that's going to have 4 elements. So you can see that I refer to coef1, coef2, 3, and 4. Okay. So these are actually model parameters, which means these are things that we will estimate with our data. Conversely, we also have x, but x is a variable. Right? So this is what changes in our data set. So we know that x essentially is going to be our stride number. So this model takes, it's one coefficient times an exponential function where it's the e to the negative coef2 times x1 plus coef3 times e to the negative coef4 times x1. Okay, so this is two exponential functions. And so what we're trying to do is to find values of coef, each of the four elements, that allow this function to best capture what the participant's data. So that's the third input to our fit NLM, and the fourth input here is our these would be our initial guess. Okay, so this would be the initial guess that we use for our to fit our model, and we specify that up here in the code. So that's just a brief overview of how you could set up a model to fit data in MATLAB. There are many different tools that you can use to fit data, and I'll refer to some of these in our GitHub. The last major thing that I wanted to highlight in this code is that we're creating tables. Okay? So we've talked about tables before. That tables can be a really useful way to store information in MATLAB because they're essentially the same format as an Excel file or CSV. So one thing that you might want to do in MATLAB, particularly if you're going to export data to a CSV for somebody to use in whatever other language they prefer, there's a function known as array to table that will take a MATLAB array and then represent that array or store that array as a table. So here I'm basically pre-allocating, so I'm creating a table that really doesn't have any information. So I just have a set of 4 zeros in a row, and then each of those for each of those columns I give them a variable name where we call these A and B slow and fast. So these correspond to the parameters that we're estimating in our double exponential. Now I'm going to save this table as this variable coefficients all. So as we go through our loop, what we do is we're going to fit each participant's data. Fit NLM outputs several different parameters related to the model, and we'll look at some of those shortly. And then I order my coefficients. That's not too critical here, but of course the fast rate should be faster than the slow rate, so we just make sure that that's correct. And then I save my here and here is where we save the model coefficients to our table coefficients underscore all. Okay. So earlier, remember, we decided that there were some data sets that we didn't think were of high quality. And so this if statement says or what it does is it looks within our data structure, it looks for this flag of good data, and if that flag is yes, so we use something called string compare. So if our good data flag is yes, then it fits the data. Otherwise, else, if it's not yes, we just store a set of nan values. Okay? So this is just an example of a way that you can provide some user input to determine what parts of your data sets are analyzed. And then finally, we store our table as a variable or mat file called group underscore data. So I will just run this code. Let me make sure I'm in the right folder. I need to go up one level. Okay. So I'm going to just run this whole script. No errors. And really what I wanted to show here is what we get out of fit LM. So we're going to look at the 10th participant. So we see that in some cases we don't actually get a good fit. That's beyond the scope of what we're covering here, but I'm happy to discuss those things later on. So let's look at our 10th participant. So you'll remember what their data structure looked like originally. One of the nice things about structures is that we can continue to add new variables as we please. So now we see that in addition to the 4 variables that we had at the beginning, we now have another variable for our model. So what's included here? So we call data10.model, And now we actually see our model structure here. So it's a nonlinear, we're doing nonlinear regression. We have estimates of each of our model parameters, standard errors associated with those estimates, p-values, and other model statistics. Okay. So this is now showing you that now I can fit a model to my data. I can do some statistics and save that with the rest of my data set. So with that, we'll stop here and we'll end with our script that we use to create our figures.